Okay, let's look at this next problem. Assign oxidation states and indicate oxidizing and the reducing agent. Some people struggle with this a little bit, and some people even forget to assign the oxidation states. So let's go ahead and assign the oxidation states here. Let's start with the zinc. This zinc here, it's an element by itself, and so the oxidation state is going to be 0. For the silver here, this is aqueous, and so this is going to be an ion. Silver always makes a +1 when it's an ion. That is the oxidation state of the silver. For the oxygen here, it's going to be a -2. Okay, and it's just to keep track of all my ions here. I have 3 of those oxygens, and so just for me, up here I write a little -6. Now the silver nitrate as a whole is neutral, and so that is going to make, I have a -6. I have the +1 from the silver, and so that's going to make the oxidation state of the nitrogen a +5. So the oxidation states for silver nitrate, the oxygen's -2. The nitrogen's a +5, and the silver itself is a +1. Now, let's go over here to the other side. The zinc is going to be a +2. That's the oxidation state. Why is that? Because each of those nitrates is a -1. I have 2 of them, so that means that the zinc, when it forms that ion in solution, is going to be a +2. And for the nitrate, we already know that the oxygen is going to be a -2, and in this case that would make the nitrogen again that +5. Alright, and then the silver by itself is going to be a 0. And so what's happening here, I have that zinc that is going from an oxidation state of 0 to a +2. It is being oxidized. Therefore, by definition, we call that zinc the reducing agent. Okay. The next thing is I have that silver going from a +1 to a 0. Its oxidation state is being reduced, going from that +1 to a 0. So the silver nitrate is the oxidizing agent. Okay, so the silver is being reduced. The silver nitrate is the oxidizing agent. So here we've assigned the oxidation state, and we have determined which one is the oxidizing and the reducing agent. These are doable. It just takes a little practice to assign those oxidation states.